Mm. Hi students, I'm Dr. Hilal Ahmed. Today we will continue our chapter carbon and its compounds. Okay. Last time we came to know about what are the different properties because of which this carbon is sharing such a great number of compounds in the world, okay, and what it is necessity and how much it is useful in organic chemistry. Today we will start with the covalent bond, and then we will move to the electron dot structure and how to make the electron dot structure of different atoms and how it is possible. Okay, so let me take my steps. First of all, I will try to make you understand that what is a covalent bond. Okay, covalent bond is a bond formed by the sharing of electrons. Do we have different types of bonds? Bond is a force. Suppose we had two atoms, atom A and atom B, for example. These two atoms or elements, they form a compound. For formation of compound, they need something to some type of force, that attractive force that makes these two different elements or atoms to be bound with each other. That force we call it as a bond. So we have different types of bonds. Ionic bond is there, covalent bond is there, ionic bond. Okay, like we say in sodium chloride. In ionic bond, what happens actually? There is no sharing of electron. Actually, sodium gives one electron to the chlorine. Okay, so it loses one electron. The chlorine takes one electron from this. So there is loss and gain of electrons in the ionic bonds. Like we have covalent bond, here the sharing of electrons will take place. Okay, from atom 1 and atom 2, sharing of electrons will take place. They will share so as to come to the noble gas configuration, noble gas electronic configuration. What does it mean? In the last session I discussed about what is a noble gas electronic configuration and how elements prefer this, why and how elements prefer this a noble gas electronic configuration. If you want to know more about this, so you have to see the last video which was uploaded in our this channel. Okay, so to attain this noble gas electronic configuration, some of the compounds, in some compounds we can directly see that they form the covalent bond. So it is formed by the sharing of the electrons between same or different. For example, we can have same carbon. Here they are sharing carbon and carbon, or it can be different carbon, hydrogen. Here we have two different elements. Okay. So these atoms, they form a covalent bond. Now the pair of electrons belongs to the pair of electrons which they are sharing. This belongs to the outermost shell of each atom. Okay, this atom and this atom. Okay, now we have carbon. Carbon forms all its bonds as covalent bonds only. Covalent LENT bonds. Okay, why carbon cannot form the ionic bond? Because we know that it is having the tetrad. It is having 4 electrons in its outermost shell. These 4 electrons it cannot give, or it cannot take more 4 electrons from other atom so as to come to the 8 electrons. Okay, to attain the noble gas configuration, electronic configuration. So it needs more energy for carbon to get the to pull the 4 electrons from other atoms. So that is why the carbon prefers the covalent bonds only. Okay, Then there are some conditions for the covalent bond. When the covalent bond formation will take place, it is taking place when we have 4 to 7 electrons in the present in the atoms. So atoms should have 4 to 7 valence electrons in their outermost shell. Then only it is possible that they can form the covalent bond. For example, carbon is there. Carbon is having 4 electrons in its outermost carbon. Then we have oxygen. Oxygen is having how many? 6. Then nitrogen is there. Nitrogen is having 7. No, nitrogen is having how many? Nitrogen is having 5 electrons in its outermost shell. Okay, valence electrons are 5 for nitrogen. Then we have chlorine, it is having 7. Okay, so we can say 4 to 7 these atoms should be present, electrons should be present in the valence shell. The valence electron should be present in the outermost shell so as to form the covalent bonds. Okay, the combining atoms should not lose the electron. They should not lose electron easily. For example, if you see in the higher for example, iron is there. Iron will never form the covalent bond. It is always form the ionic bonds. Iron is having outermost shell many, sometimes it is 3. We can say 3 electrons can be there, 5 it can also show, share or 2 also it can show. Okay, this iron, it is outermost that layer is there, it easily loses its electrons of the outermost layer. That is why it is forming the ionic bonds. Okay, so but in case of elements like carbon, oxygen, nitrogen, chlorine, fluorine also, okay, such elements, they don't have this property. They have the property of they cannot lose the electron easily. Okay, then these two combining atoms which we have, for example, we have A and B, they want to make the covalent bond in between. They should not lose the electrons easily also. This is one of the important thing. Then they should gain the electrons easily. The gaining property should be also there. Gain electrons easily. This is the third point. What? They should have ability to gain electrons easily from the sharing element, that's atom. Okay, then the difference in electronegativity of two bonded atoms should be low. So electronegativity, ELECTRO, electronegativity, difference in the two atoms should be low. It should not have high electronegativity, it is having more low, and it is having more lower, it is having more high. The difference between the electronegativity, what is electronegativity? It is actually the force. Electronegativity is a type of force of attraction by which the nucleus which is inside present, that attracts its outermost electrons, okay, which are present in the outermost shell. Okay, so it is different for different atoms because different atoms have different size. Atomic size is different, a number of electrons, protons is different, atomic number is different. Because of this difference in their because of the difference in their chemical nature, we can see that electronegativity will be also differ. So the electronegativity between these two pairing electron atoms should not be more, okay, the difference. Then there are some physical properties also of the covalent bonds. We can say that they are generally liquids. Such compounds which are formed by the covalent bond, they are generally liquids, or they can be gases also. Liquids and gases, okay. But some covalent compounds may also exist as in the solid form. Then they are insoluble. Mostly we can say they are insoluble in water. They are insoluble with each other. They cannot easily get mixed with other atoms. Okay. Then they have generally the low melting and boiling points. Also we can say they do not conduct any electric current. They are bad conductors of electricity. Why? The current we can see when electricity passes means there should be the electrons, valence electrons present in that metal. Since metals have a sea of electrons in their outermost shell, okay, which are always in the moment, electrons there in the case of metals, whatever metal you can talk about. But here we don't have that. There is no electron now present for conducting the electricity, because for conducting the electricity we should have a positive charge or we should have a negative charge. Here we cannot see any positive or negative charge in case of covalent compounds. Okay, that is all. Let us move to our next topic, that is how to form the Lewis dot structures. Lewis dot structures of covalent bonds, covalent compounds, covalent compounds. How we can form the Lewis structures, Lewis dot structures of the covalent compound. So Lewis dot structure we have discussed in our last topic. Like I said something when we are talking about hydrogen gas, it is actually hydrogen, it is one electron which it is mutually sharing with other hydrogen, so it is making the like structure like this. So this can be the electron from this and this can be the electron from, it is counter hydrogen. So this is called the Lewis dot structure. Here we are showing the electrons in the form of dots, okay, which just help us to know how many electrons and how they are shared with each other. First of all, we have to write the electronic configuration of all atoms present in that molecule. We should know, first step is we have to write electronic configuration. So electronic configuration we know in the ninth till now, configuration means what? How many electrons are there? For example, this is the metal of this hydrogen metal atom, so we have one electron, so it is having one electron in it, okay. Then we have carbon. For carbon it is what? It is having first 2, then second 6. So this is the electronic configuration. In the first, the innermost shell it is having 2 electrons, and in the outermost shell it is having 6 electrons. So total will, we have 4 electrons only, sorry. So the total atomic number is 4 plus 2 is equal to, it is having 6 atomic number. So this is the electronic configuration we should make. Then we have to identify how many electrons are needed by each atom to attain the noble gas, configuration. How many electrons are needed? How many electrons are needed? So what does it mean? For example, for carbon, the noble gas configuration is like this: 2, either 2 or it should be 8. Okay, outermost shell should have 2 electrons only, as we call in case of the hydrogen, or it should have 8 electrons in the outermost shell. So that becomes a noble gas configuration. Since carbon is having inside 2 but outermost shell is having 4, so how many electrons are now needed? How many electrons are now needed for carbon to attain the noble gas configuration? So it means 4 electrons. See, 4 plus 4 is equal to 8. For oxygen, suppose if we are talking oxygen, atomic number is what? 8. Okay, so what is its electronic configuration? It is 2. First shell will be always 2 electrons occupied, so second shell is 6. 2 plus 6 equal to 8. Now to attain the noble gas configuration, how many electrons are needed here? Okay, so 8 minus 2, 8 minus 6 equal to 2. So it means oxygen needs only 2 electrons to attain the noble gas configuration. By this way we should know how many atoms. For example, let us see the hydrogen. For hydrogen, what is the atomic number? Atomic number is 1. To attain the noble gas configuration here means helium. Helium is the nearest noble gas, near to the nearest noble gas of hydrogen. So it is having 2 electrons. Okay, so for hydrogen to attain the noble gas configuration, that is to become 2, it needs how many electrons? It needs 1 electron. So this also we should know. So it needs 1 electron. Then nitrogen. So nitrogen is having atomic number 7. When we talk about atomic number 7, then let us make the electronic configuration. Electronic configuration will be, first shell will be 2, then second shell will be 7 minus 5. Okay, so to attain the noble gas configuration for nitrogen, how many electrons are needed? 5. So we can see it is 5 here. So total it should be 8 actually. 8 minus 5 equals to 3. Very good. So we need 3 electrons for nitrogen to attain the noble gas configuration. By this way we should have a full list of, so whenever you are talking about making the electron dot, first of all you should know the electronic configuration. So in first shell how many electrons are there, how many second, how many. Second thing is to attain the noble gas configuration, how many electrons are needed. Okay, how many are needed. Then next is we should share the electrons between the atoms in such a way that all atoms in a molecule should attain the noble gas configuration. So when we are making atom A and atom B, we have to make share their electrons in such a way that both A and B should get equal number, should attain the noble gas configuration in their outermost shell. For example, there we are sharing 3. For example, it was what? So okay, it was, for example, it was like this. It was A atom was having how many? 1, 2, 3, 4, 5 electrons in its outermost shell. B is also having the 5 electrons in its outermost shell. So what we will do, we will share the electrons by both A and B in such a way that A should also attain the electronic the noble gas configuration, that is the number of electrons in its outermost shell should be, for example, here 8, and B should also have 8. A should also have 8, B should also have 8. That is the noble gas configuration when we are talking about that. So we have to make it. Let us see some of the example. Example number 1. We have hydrogen, H2. You can see hydrogen always in H2 form, not H. It will be always, so it is a gas. Let us try to draw the electronic configuration, Lewis dot structure of hydrogen. So let us make the hydrogen 1, and this is one more hydrogen. So we have here hydrogen is having atomic number, we know it is 1 only. So outermost electron, it is having the 1 electron only present in its shell. So this is its electron, and this is the electron of one other hydrogen. So this is 1 second. To attain the noble gas configuration for hydrogen, we know it is 1 needed. Okay, so this 1 it will get from this, and this hydrogen will get from this. So we saw here something we are combining here. This area, this is our covalent bond. This is our covalent bond, or we can see the structure which we have drawn here now. It is Lewis dot structure of hydrogen. Okay, this is the HH single bond, only HH single bond. Now example number 2, let us talk about oxygen. Oxygen will also not be available like this O, but when we see oxygen is always available in O2 form, O2. So let us see first of all in oxygen how many electrons are there present in its outermost shell. How many are there? Okay, how many are there? In its innermost shell we have 1 and 2. Outermost shell, how many are there? So hydrogen, we should know the atomic number of hydrogen means hydrogen, helium, lithium, beryllium, oxygen. Hydrogen, helium, beryllium, boron, carbon, nitrogen, oxygen. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So it means its atomic number is 8. Atomic number is, we should know this also. This was taught in the 9th class. Atomic number of carbon is 8. Good. So let us see what is its electronic configuration. Inside there will be 2 electrons as usual. So outside means how many will be left? 1, 1 2 3 4 5 6 7 and 8. 1 2 3 4 5 6. We have now 8 electrons in it. So one more oxygen. For that oxygen also we will draw the same thing. So 1 2 3 4 5 6 7 and 8, because atomic number is 8. So these are the two oxygens. Now these two oxygens, how they will form a covalent bond? What we can do, this oxygen needs how many electrons? It needs 2 electrons only. This oxygen also needs 2 electrons, because we have 6 electrons. It should be actually 8 electrons, as we see in case of as we can see in case of noble gas configuration. So 2 electrons, they will now mutually share these 2 electrons. So let us draw it again. This is one oxygen, this is one more oxygen. Okay, so no, when we make these two oxygens near to each other, near to, how it will look? It will not look like this. It will look, first of all, let us check the electrons which they are going to share, because 2 electrons it should get from here. This also should share 2 electrons with this. These are the 2 electrons. This is oxygen here, this is one more oxygen. 1 2, it has 6 electrons only in its outermost shell. So 1 2 3 4 5 6, 1 2 3 4 5 and 6. Okay, these are the 6 of this oxygen, these are the 6 of this oxygen. So what we will do, we will now make the electron dot structure. This is the electron dot structure. You see now 1 2 3 4 5 6 7 8. So it got the 8 electrons. Now for this oxygen, 1 2 3 4 5 6 7 and 8. So this is the electron dot structure of oxygen molecule. Okay, we have some more examples like nitrogen. In nitrogen, I will tell you the atomic number for nitrogen is 7. Okay, it is 7. It is having 5 electrons in outermost shell. So to attain a noble gas configuration, it needs 3 electrons for noble gas configuration. So I want from the students what can be the, how can be the electron and dot structure of nitrogen. Okay, likewise we can go for other atoms, like we have H2O. Okay, in H2O, how this is the oxygen. Okay, this is one H, this is one H. As we know, these are the electrons of oxygen, 1 2 3 4 5 and 6. It is having 6 electrons. Okay, hydrogen also we have 1, here also we have 1. So hydrogen needs only 1 electron. It will get shared it with the oxygen. This hydrogen also needs 1 electron, so it will share it with the oxygen. But oxygen itself needs electron from 2 hydrogens, so it will share it like this. Oh, like this. See how it is making. Now total number of electrons in oxygen will be 1 2 3 4 5 6 7 8. Okay, so it is noble gas configuration is now full. It is not having any problem when we talk about its noble gas configuration. So my students, try to draw the electron dot structure of carbon dioxide, CO2, and there you have to check carbon how many valence electrons and oxygen how many, 2 oxygens are there. Then you have to draw the electron dot structure of what? Methane, CH4. Okay, try it by yourself. So then you have to send it in my group, WhatsApp group. That is all for this. Then let's move to our next topic, that is the compounds made up of hydrogen and oxygen, and what are hydrocarbons. What is a hydrocarbon? What is a hydrocarbon? It is a simple thing, the compounds which are made up of hydrogen and carbon. The compounds made up of hydrogen and carbon, we call them as hydrocarbons. But these hydrocarbons, when we try to see inside, some hydrocarbons will be having single bond and some will be having double bond. Okay, single bond is the case where the sharing of one electron from two, suppose this is atom A and this is atom B, when they are sharing only one electron with each other, so it will be what? It will be single bond. So when we have atom A and we have atom C, they are sharing two electrons with each other, two electron pair of electrons with each other, so it will be a double bond. But when we have the other case, that is atom D, for example, so they are sharing with each other three electrons, so here it will be, this is single bond, this is double bond, and this will be a triple bond. Okay, so it is easy to understand. So based on this, whether it is having single bond or it is having more than one bonds, we call it them as saturated hydrocarbons and unsaturated, very good, unsaturated hydrocarbons. Okay, saturated hydrocarbons and unsaturated hydrocarbons. Saturated and hydrocarbons are the hydrocarbons where we have only in that compound, in that hydrocarbon compound, we have only single bonds. For example, this is carbon, and they are sharing these lines what I am drawing here, these hyphen like structures, these are the actually bonds. Okay, these are the bonds formed by it. So carbon is making here single bonds, all here it can be hydrogen, whatever it can, there are possibility of many other atoms also which we can keep it here. Okay, then we have unsaturated hydrocarbons. So I hope you understood. In unsaturated hydrocarbons, what we have, carbon will be double bond with carbon. Okay, it will form the double bonds. Okay, or it can form the triple bonds also, 1 2 3, this is one carbon, this is one carbon, this is a triple bond and this is a double bond. Okay, so good students, so this is all. Now based on the name, we can say that we have different carbons. Since we know that the carbon is having one important property, that is, it is having catenation property. Catenation property means it forms the series of compounds. It forms the series of compounds with other like atoms. Okay, which also form the covalent bonds with it. So based on that, we can have all those hydrocarbons which are saturated, we call them as alkanes, ALKANES. Check the spelling, alkanes. In alkanes, the carbon atoms always have a single bond with them, okay, in between them. And we have here double bond, they are called alkenes. In the alkenes, these are the types of hydrocarbons where we have double bond, at least one double bond is present. Okay, one or more double bonds. But when we have triple bonds, we call them as alkynes. Okay, in case of alkynes, YNE, here ENE, ANE. Okay, in alkynes we have the triple bond, at least one triple bond present in that carbon hydrocarbon. Okay, then we can create the, as we saw in the last session, we can create the electron dot structure also for all these. It is always possible, no problem for that. If you see the electron dot structure of, for example, let us see, we have an atom like we say methane is there, we have methane. In methane we have CH4, one carbon is there and 4 hydrogens are there. The structure will be like this: hydrogen, 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 and hydrogen. This is the structural formula and this is the molecular formula. Okay, in molecular formula we are just giving the idea that how many and which atom is present and how many number of atoms are present there. But in case of structural formula, we draw the bond also, how those atoms actually they look like in this compound. Okay, this is the structural formula of methane. Okay, so here we can make the electron dot structure also. For example, let me draw the electron dot structure of methane. This is one carbon. Okay, these are hydrogens here. So you see, like this it will be made. Okay, now we have, see, each carbon is now paired with one of the electron of each hydrogen is paired with one of the electron of carbon. Likewise, this carbon is paired with each one electron of each hydrogen here. So this is the electron dot structure of methane. The formula this, structure formula this. Now what about the ethane? ETHANE. In ethane we have the molecular formula as C2 and H6. C2. I will try to draw the structural formula first. This is my ethane. Okay, H6. You see how it will come. Okay, this is coming this way, 1 2 3 4 5 6. So H6 and C2, 1 2, carbon 1 and carbon 2. Now let us try to draw the electron dot structure of ethane. It is very easy. What we have to do is, actually we have to see how many electrons can be shared here. So it is carbon, this carbon, it is sharing one electron with other carbon. Okay, good. Then we have each carbon, it is sharing one electron with other hydrogen. Okay, these are the electrons of hydrogen. For example, I will try to draw it. These are the electrons of carbon. Okay, so see how it will like for this for each carbon we have to draw it. For each carbon, it is for each, how many atoms are there? One, see, hydrogen is one atom. For this hydrogen, what is the electron cloud? Like this is the electron cloud of this hydrogen, this is the electron cloud of this hydrogen. Okay, this is the electron cloud of this hydrogen. Likewise, I am trying to draw it. You can see, okay, each hydrogen is paired with the carbon. Now for each carbon, carbon number 1, let us see, it is 8 electrons, 1 2 3 4 5 6 7 8. So we have to make it accordingly, like this. See it, this is for this carbon. Then what about this carbon? So let us see, try to draw it. This is the electron dot cloud of this carbon. So this is the Lewis electron dot structure of electronic configuration of ethane. Okay, let us go to the double bonds. When we have the double bonds, like methane is not possible, we can see ethene, C double bond C, and try to draw the hydrogen atoms here. So we can see this is the structural formula, the molecular formula ethane. I forgot here, it is actually C2H4. Yeah, H4 only, not these two H's will not come, because each carbon has 1 2 3 4. Okay, so what will be the electron dot structure? It is simple only. We can have 1 2 3 4, 2 carbons. This is the double bond here, this is carbon, and this is one hydrogen, this is one more hydrogen, here one more hydrogen, here one more. This is the electron of this hydrogen. Try to draw it. These are the electrons which each carbon will share. So each hydrogen got its own electrons. Now let us see. Okay, try to draw it. Here also we have the same. And each carbon, let us see the electron circle of this carbon. Okay, good. Sorry, it is like this. So it will be like this for this carbon. So this is the electron dot structure of ethene, ENE. Why double bond is? So students, you have to try to draw the electron structure of ethane. So how ethane is? It is C2H2. The molecular structural formula will be like this. So I want from the students what about the electron dot structure of. So with this we will we will conclude our today's topic. Till now we have seen the covalent bond and how we can draw the electron dot structure of individual atoms, and in case of other hydrocarbons and what are hydrocarbons. In the next session we are going to check how to draw the molecular structure formula, and what about the nomenclature, how to give name to the different hydrocarbons which are present. Okay, so till we are back, the questions which I mentioned in this video, you have to answer my questions and you have to send it to me as soon as possible. Okay, in the group, our WhatsApp group is already there existing. Okay, in that group I am expecting the answers from my students. Okay, so till we are back,